So in a nutshell, decision trees know how to ask the right question, and knowing how they think helps you understand the rest of a tree-based machine learning algorithm like random forest, AdaBoost, XGBoost, and GBM faster. Let me explain what I'm talking about. Every day you want to decide what to eat, you go through a series of questions that help you make that decision. For example, do you order food or cook it yourself? And based on your answer, new questions comes in. As if you want to cook it yourself, you're pretty much restricted to ingredients you already have or dishes you know how to make. So as a human, you go through these questions and put them in the right order naturally. And this is what decision tree tries to do using the data it has. Let's look at the simplest example possible. Let's say you have these 15 points of data and you want to classify them into either black circles or red triangles. Notice that we have only the order from 1 to 15 and we want to make a classification out of that into red triangles or black circles. The decision tree will pick a random question and assess it. So it starts with the following questions. Is the order of the shape less than or equal 8? If yes, it goes to left, no goes to right. So with the yes, it gives us 6 black circles and 2 red triangles. With no, it gives us 7 red triangles. And as a side note here, in decision tree lingo, every question we ask is called a node. And if this question is the first question, like the example that we have here, it called the root node. And as you can see, we ended up with 7 triangles on one side and a mix of circles and triangles on the other side. So we call this a pure node as we ended up with only one class, triangles, and this as an impure node because we ended up with a mixed circles and triangles. So the decision tree can carry on with this start to reach all nodes pure. However, it's smarter than that. Decision trees know the importance of asking the right question first, as it will simplify the process. If it starts with a question, is the order less than or equal 6, it reaches pure node from one split. Sweet! By the way, the impurity of any node can be quantified using a mathematical metric called Gini Index. Let's not worry about the math now, as in my next video, I will walk you through a calculated example. So don't forget to hit that subscribe button, but it's not always possible to have a pure nodes from the first 2 questions. Let's look at a trickier example. In this example, decision tree assesses multiple first 2 questions and sees the one that gives less impurity in its resultant node. Following along, as we did in the previous example, we end up with 3 results, and our goal to get the least impurity. So as the third trial has mixed classes on both branches, it makes it the most impure, so we cross it out. So we left with 2 potential starts, less than 2 and less than 4. But both of them has one pure branch and one impure branch. Which one of these questions leads to the least impure result? Since I promised to keep this video with no math, let's think of it as this. This one has 5 circles and 8 triangles, while this one has 3 circles and 8 triangles. So that one has more diversity in it, since the 5 to the 8 is larger than the 3 to the 8, which makes it has more diversity in it, hence more impurity. So we cross it out. And we repeat the same exercise till we reach all pure nodes. Yes! So what I just described is called the CART algorithm. And this is the brain of any decision tree. So CART makes the decision tree ask the right questions first. A question that when answered, it gives us more information as possible. So if you go back to our first example, these 2 questions, one of them gave us the right answer straight away, and the other one we needed to ask another question to make it to the answer we are after. So as you can see, at each node, CART look at the best split or rule that minimizes the impurity of the resultant nodes. And this idea of changing some parameters to minimize some metric is a common idea in machine learning algorithms. And if you want to know more about this concept, check my previous video in the description. So, if you like the video, please hit like, share and subscribe. And stay tuned!